Hi, my name is Hongyu Li from University of Tsukuba, Japan. Today I'd like to present our work about MRC examples. Answerable by BERT without a question are less effective in MRC model training. Here is the contents of my presentation. Firstly, I will give a brief introduction on the background and what we have done. This figure shows a typical example of MRC, machine reading comprehension, which contains a table of a contest, a question, and an answer. Here we have a contest about precipitation and a question related to that contest. They are used as our MRC model input. Then the model will output the best corresponding answer. In the field of MRC, it is known that most recent MRC models, like pre-trained model BERT, have outperformed human performance in a certain benchmark challenge. However, in Kaushik's work in 2018, they established sensible baselines for the several MRC datasets, finding that question-only and contest-only models often perform surprisingly well. And the paper shows that Squad is designed more carefully than other datasets and achieved relatively lower F1 scores on question-only and contest-only models. Finally, they drew the conclusion that published MRC datasets should characterize the level of difficulty and specifically the extent to which questions and contests are essential, and also follow a paper reporting improvements or to report performance both on the full task and variation of meeting questions and contests. But in our paper, we concentrate more on the difficulty of every single MRC example and split the 87,599 training examples of Squad 1.1 into 12,487 easy-to-answer examples and 95,112 hard-to-answer ones. And then we have done two evaluations of the two classes. The first one is an evaluation of the position of the answer within the context. Here are two easy-to-answer examples, with the answers located exactly at the beginning or the end of the context. We wonder if there is some relation between the difficulty of examples and the positions of answers within the context. So we compare the distributions of answer positions within the context between the two classes and found that answers of easy-to-answer examples tend to be located near the beginning of the context as compared with those of the hard-to-answer examples. Nextly, we evaluated the effectiveness of hard-to-answer and easy-to-answer MRC examples based on the performance of each class when used to fine-tune the BERT MRC models. As the evaluation result shows, when the number of training examples are restricted to be the same, the model trained with hard-to-answer examples significantly outperforms the one trained with easy-to-answer examples. However, unfortunately, the performance of hard-to-answer examples is almost comparable with that of examples randomly sampled from the training set of Squad 1.1. Here is the detail of our approach to splitting examples into easy ones and hard ones. We first apply a tenfold cross-validation on the training set of Squad 1.1. When testing through the eightfold of the cross-validation, we fine-tune a BERT model on the MRC task with 90% of training examples with questions used, and test the model against the remaining 10% of the examples with questions not used. According to whether the test examples are correctly answered by the MRC model, we split the set of test examples TSI into answerable and unanswerable examples, namely A2 and UA2. Similarly, we fine-tune the model with 90% of training examples with questions not used. When testing with the model against the test examples with questions used, we got A3 and UA3. And when testing the model against the test examples with questions not used, we got A4 and UA4. Based on the three sets of answerable examples, we then split the 10% of examples used for testing, namely TSI, into easy-to-answer examples and hard-to-answer examples. Specifically, we define the easy-to-answer examples EI as union of the three answerable subsets A2, A3, and A4, and the hard-to-answer examples HI as the complement set of EI. The splitting process was repeated 10 times, and finally we got E as the union of all easy-to-answer examples, and H as the complement set of E. As a result, the 87,599 training examples of Squad 1.1 was split into 12,487 easy-to-answer examples and 75,112 hard-to-answer ones. Finally, the last parts are conclusion and future work. So in our work, we split 87,599 training examples of Squad 1.1 into 12,487 easy-to-answer examples and 75,112 hard-to-answer ones, and found that answers of the easy-to-answer examples tend to be located near the beginning of the contest. When the numbers of training examples are restricted to be the same, the MRC model trained with hard-to-answer examples significantly outperforms the one trained with easy-to-answer examples. The performance of hard-to-answer examples is almost comparable with that of training examples randomly sampled from the training examples of Squad 1.1. And then, before talking about future work, I'm going to introduce Swayam-Deepa's work. In their paper, they use the model's confidence and the variability of this confidence across epochs for each example to build data maps. And they identified three areas in the data map. As shown in this figure, the easy-to-learn area on the top can aid optimization. The ambiguous area in the middle is useful high performance, and hard-to-learn area at the bottom is often corresponding to data errors. So our future work includes, firstly, applying the framework of Swayam-Deepa's paper to MRC tasks and investigating the difference of our notion of easy-to-answer or hard-to-answer examples and their notion of easy-to-learn or hard-to-learn. And secondly, we will apply the analysis procedure of our paper to several popular MRC benchmark datasets other than Scott. And thirdly, we will do a deeper analysis of the characteristics of easy-to-answer or hard-to-answer examples to find out features that are related to the disparity of training effectiveness.